So today we're going to look at a shortcut to long division of polynomials called synthetic division of polynomials. So it'll just kind of help streamline the process, make it a little bit quicker instead of using long division every time you want to divide something out of a polynomial. So here are the steps for using synthetic division, and then we'll take a look at a few examples. So we're going to use synthetic division when a zero can easily be found. So if they tell you like we're dividing by, we'll say x minus 4, that would mean if we were to set that equal to 0, we would get x equals 4. So we have a nice integer value for the 0. And if that's the case, we can go ahead and use synthetic division instead of long division. So to start us off, we need to write all of the coefficients from the original polynomial in a horizontal line. So we're going to just create a column of those coefficients and we drop the variables off. We have to use placeholders. So for example, if our polynomial was a 4x to the third plus 2x minus 7, we're missing the x squared term. So when we write our coefficients of 4, 2, and negative 7, we have to put a 0 in there. So we would write them as 4, 0, 2, and negative 7. Then we're going to go ahead and make a box around those coefficients, and then the 0 goes outside of the box. Then you're going to end up carrying down the first coefficient from the polynomial, put it below the line, and then you're going to follow a multiply add pattern that we'll take a look at in just a minute with some examples. But essentially, you're going to take your the 0 of 4 out here, multiply it by that coefficient, put it here, and then add these terms to get the value that's going to go next. And then you repeat. You're going to multiply and then add until you get to the end. Then you'll write your final answer with the variables included. So you'll put those x variables back in, and then potentially the last value would be a remainder if you have one. So at this point, I would say pause the video, write down your steps for synthetic division, and then when you're done recording your steps, you can move on to the next or resume the video where we're going to look at a few examples. So here's our first example. We're dividing by x plus 2. We've got our polynomial here. So the first thing that we're going to do is we're going to set up this box with the coefficients from the original polynomial right across. So here we've got a 1x to the third, a negative 4x squared, a 2x, and a negative 3. Then we look at what we're dividing by. X plus 2. If we set that equal to 0, our 0 is negative 2. So that 0 goes right outside of the box. Then we're going to drop down that first coefficient. So we're going to put that 1 below the line. And then we follow a multiplication and addition pattern. So I'm going to take negative 2 times 1. That gives me negative 2, which goes right above the line. Then I add this vertical column. So negative 4 plus negative 2 is negative 6. Then I repeat. I multiply negative 2 times negative 6 is positive 12. I add 2 plus 12 is 14. I multiply negative 2 times 14 is negative 28. And then I add one last time. So negative 3 plus negative 28 is going to be negative 31. Then I have to put my coefficients back in. So you can think of this in one of two ways. This last number here is always going to be the remainder, and then you count up from there. So this would be our constant term, this would be our x term, this would be our x squared term. So I would write it as a 1x squared minus 6x plus 14 plus my remainder of negative 31 over whatever we were initially dividing by. So same idea as the long division, so over x plus 2. And that would be my final answer. Your other option for putting those variable terms back in is that we started with an x to the third and we divided out an x to the first. So that means the result is going to be an x squared, and then you're going to count down from there. So it would be the x squared, x, constant, and remainder. Here's another example. Again, we're going to look at this polynomial. We're going to write those coefficients across the top of the box. But this one's a little different. We have an x to the third and x squared, but there's no x term. So we have to put in that placeholder for x. Otherwise, our final result will not be correct. So then when I put those coefficients in, I've got the 3x to the third, a negative 2x squared, a 0x, and a 5. Then I need my 0. So I take x minus 1, set it equal to 0. So that gives me x equals 1. So that 1 is what goes outside of the box. I always then start, once it's set up, by dropping down that first coefficient, and then I start my multiplication and addition cycle. So 1 times 3 is 3. Negative 2 plus 3 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 5 plus 1 is 6. Then I've got to go put those coefficients back in. So again, I can either say, okay, I started with an x to the third, and I divided out an x, so this is going to be a 3x squared, my x term, my constant, and my remainder. Or this is always my remainder, constant term, x, and x squared. So my solution here would be a 3x squared plus x plus 1 plus my remainder of 6 divided by what I was originally dividing out, so the x minus 1. Okay, so another example here. Again, when we go ahead and set it up, we take those coefficients. We're not missing any x terms here, so I've got a 5x to the third, negative 4x squared, 3x, and 5. And again, just be careful, like watch your signs. If I forgot to record that negative 4 there, then my final answer is not going to be correct. So we do want to make sure that we're carefully setting up. X minus 4 is what we're dividing by. So if I set that equal to 0, I get x equals 4, and that 0 goes out front. I then drop down the first coefficient, and then I multiply 4 times 5 to get 20. And then I add negative 4 plus 20 to get 16. Then I multiply, so I've got 4 times 16, which will give me 64. And then I add, and that's going to give me a 67. Then I multiply 4 times 67. That's going to give me 268. And then I add, that'll give me 273. So then I've got here my remainder, my constant term, my x term, my x squared. Or again, if I work down from what I started with, I had x to the third and I divided out an x, so x squared, x, constant, remainder. So this will be a 5x squared plus 16x plus 67 plus my remainder of 273 over the x minus 4 that I was dividing out. Okay, so in this example, again, when I look, I'm missing my x squared term. So my coefficients are going to be a 2x to the third, 0x squared, negative 7x, and 1. And then I've got x plus 3 equals 0. So my 0 is negative 3 on the outside. I then drop down my 2. Negative 3 times 2 is going to give me a negative 6. 0 plus negative 6 will give me a negative 6 here. Negative 3 times negative 6 will give me a positive 18. Negative 7 plus 18 will give me 11. Negative 3 times 11 will be a negative 33. And then 1 plus negative 33 will give me negative 32. So then here, say I work backwards from the top, I divided out an x from the x to the third. So this is going to be an x squared, an x, a constant term, and a remainder. So 2x squared minus 6x plus 11 plus negative 32 over x plus 3. So your assignment is on page 177 in your textbook, questions 11 through 18, and you should be using synthetic division for each of those. So give this a shot. It's much faster than the long division. It might seem a little bit tricky at first just because we're getting rid of all those variables and then having to put them back in. But in the long run, you'll be able to complete the problems a lot more quickly this way.